All right, so we have talked about solving quadratic equations what seems like forever at this point. And they are applicable absolutely everywhere. I mean, you have quadratic equations all over the place. But you also have quadratic inequalities. And so think about when we did equations versus inequalities. The only difference is instead of an equal sign, you're going to have a greater than, less than, or potentially not equal to, right? Inequalities, meaning they're just not equal. So with quadratics, you have to go back in your brain and think about what that means. Because your quadratic could be potentially greater than 0. Now remember, when we factor those quadratics, you have two things multiplying with each other. So if I'm multiplying two things and I'm getting something greater than 0, it means I'm multiplying two numbers and I'm getting a positive. There are two ways to multiply two things and get a positive. It means that those parentheses that I come up with when I factor could be positive, positive, or negative, negative. Because if I multiply a positive times a positive, I will get a positive. If I multiply a negative times a negative, I will get a positive. So when your quadratic is greater than 0, it means that they are either both going to be bigger than 0 or both less than 0 when you factor them. So normally we would factor and set them equal to 0, but that's not what's going to happen with these. The other option is that your quadratic, when you get this, is going to be less than 0. Well, less than 0 can also happen two ways. If I am doing something less than 0, and I have two different parentheses, then that means that the first one could be positive and the second one could be negative. Or it means that the first one is negative and the second one is positive. So as we do these, we're actually going to do them the same way that we would solve. We're going to do it by factoring. But at the very end, instead of setting them equal to 0, we're going to actually try two different things and see which one actually works. Because these are going to be a combination of our and, if you remember and and our ors. And so we're going to create these inequalities that actually either cross each other or go opposite directions. And so the first one we're going to do is when we have something greater than 0. All right, so in order for my answer to be greater than 0, both of my parentheses have to be the same sign. So I am going to test them. I'm going to test them where they're both positive, and I'm going to test them where they're both negative. And then I'm going to come up with the correct solution to whether they are positive or negative. So let's look at this. This is a very easy factoring that they've given us. I am looking for factors of -2 that give me -1. We have a prime number there. So I am going to factor this with a -2, x minus 2, and an x plus 1. All right. So then we have two scenarios that could happen. X plus 2 and x plus 1, or x minus 2, x plus 1 could both be greater than 0. That's my first scenario. So I'm going to say x minus 2 is greater than 0, and x plus 1 is greater than 0. That's the first thing I'm going to test. Or we have another scenario. The other scenario is that x minus 2 is less than 0 and x plus 1 is less than 0. So either they're both positive or they're both negative. So let's see what happens when I do this. X could be greater than 2. And x could be greater than -1. If I were to graph that guy, where do they start crossing? Because and means where they cross. So if I have something, think about your number line. I have a -1, 0, 1, 2. I have a positive 2. This guy starts here and goes. This second guy starts here and goes. At what point do they start crossing over? Here. So that is my answer on this side. On this side, the answer is just going to be where from 2 and up, right? Let's look at the other one. X could be less than 2, and x is less than -1. Where do they start crossing on that side if we're talking about less than? Well, they start crossing at the lower one, don't they? Yes, everybody agree they start crossing at the lower one? So then I end up with an or problem. X could be less than -1, or X could be greater than 2. Both of those will work. And so when you have a problem like this, you're going to just combine the two answers. But when it is an and problem, right, you're going to end up with one of them when they're facing the same direction. Because we are saying X is either bigger than both of them or X is smaller than both of them. So for these, you're going to say, oh, he's going to be bigger than the largest one, smaller than the lowest one. And that's how these and problems are going to combine for you. With less than, you actually see a different pattern. You want to do exactly the same process. So for this, you do want to get it in standard form, meaning I'm moving everything over to one side. So I'm going to have 2x squared. I'm going to move that 5x over, and I'm going to move that 1 over. And so now I'm looking at less than or equal to 0. All right, so if I want my final answer to be less than 0, then that means I want my final answer to be negative. So I'm going to do my factoring exactly the same way, right? I'm going to factor. All right, and again, you can do your rainbow method or whatever method you do to factor. You can double check it, 2x, x squared. We're going to get a positive 6 and a negative 1. That gives me 5, and I'm going to get a negative 3. So you can quickly check your foiling for factoring there. Yeah, so if you remember how to do it, you're going to say 2 times that negative 3 gives you a negative 6. I'm looking for factors of negative 6 that add up to 5. That's a negative 1 and a positive 6. So I'm going to rewrite it 2x squared minus 1x plus 6x minus 3. And then I'm going to factor by grouping. So here an x comes out, I have 2x minus 1. Here a 3 comes out, I have 2x minus 1. So my final factoring is going to be that 2x minus 1 and that x plus 3. Because if I have less than 0, it means I'm multiplying and getting a negative. And the only way you do that is for one to be positive and one to be negative. But you still have 2 scenarios. So I could say, well, the first scenario I'm going to test is that this guy is positive and that guy is negative. All right, so I would say, well, 2x minus 1 is positive. That means it's greater than or equal to 0. And x plus 3 is negative, which means it's less than or equal to 0. So I'm going to test that one. And I'm still creating an or between my scenarios. And so if I look at this, I would say, well, x is greater than or equal to 1/2, and x is less than or equal to negative 3. We have a problem. What number is greater than or equal to 1/2, and it is also less than or equal to negative 3? Think about it on a number line. If I have greater than or equal to 1/2, that's here, here, in this direction. Less than or equal to negative 3, that is here in this direction. Where do they cross? They don't cross. So on this side, on this scenario, I have the empty set. All right? So then I'm going to test the other scenario. The other scenario looks like this. 2x minus 1 is less than or equal to 0, and x plus 3 is greater than or equal to 0. which means that x is less than or equal to 1/2, and x is greater than or equal to -3. This does work. So in this scenario, one of them is going to give you an empty set. The other one is going to give you a solution. What happens on your less than problems is that the smallest answer starts here. It is less than or equal to your variable, which is less than or equal to your largest answer of your two, right? So if I take this answer and combine it with the empty set, I actually just get this answer. And that's what you're going to see over and over with these less than problems. You're going to see one that goes opposite directions and they never cross, and then the other one's going to work.